This is section 12.1. We're discussing writing and evaluating functions, identifying domain and range in a table and in the equation. We have covered this before, so this should be review for you. If you are still unclear in being able to identify the domain and range in multiple ways, then it would be good for you to watch this video. Otherwise, if you completely understand it, then you can go right to the homework. All right, so you're doing page 539, 1 through 28 odd, and 29 through 31 all. All right. So a function is like a machine. We can put a number in, and we get a number out. We call what we put in the input, and we call what comes out of it, the result, the output. It's almost like there's a rule in there that's making that happen. When I put a 2 in, I get a 10 out. There's something that goes on in there. And that rule is the function. So if I have a 4, what's going to come out? We can probably predict at this point that it'll be a 20. So the rule for this function is that every time a number goes in there, it ends up being multiplied by 5. So we can say that whatever the input is, if it's an x, it's going to be multiplied by x, so the rule would be 5x. Okay? We can predict 7, we can predict 100. We don't need to go in order. Okay? So we call our output y, or the f of x, and we call our input x. We can also make a table out of this data. So if I had an equation that looked like this, with 2 variables, I could make my table and it looked like this. We also call the input the domain and the output the range. Okay, so that was the table. All right, a relation is any set of ordered pairs. The domain is all of your input values, all of your x values. The range is all of your y values. So in this relation, number 1, the set of ordered pairs, the domain, we would say, is all of the x values. So it would be 2, 3, 4, and 5. And we would say that the range is all of the y values. It's all of our outputs. So that would be 5, 7, 9, and 11. And if a number is repeated, we only write it once. All right, so I'd like for you to try the next one. Pause the recording. Let's check our work. So our domain -3, -2, -1, and 1. Close the braces. And our range be 5, 7, 9. Oh, whoops, I'm copying up there. It would be, let's go, 10. I don't need to write 10 twice. And I have a 6. Okay, so the domain and the range, there it is. All right. We can have word problems where you can write out the rule. Logan assembles outdoor barbecues for $8 each. Write a rule that represents his pay Y in terms of, that means Y in terms of, it's almost like the, where Y is the result and whatever else is on the right side. Y in terms of the number of barbecues he assembles. So if they're $8 each, whoops. If they are $8 each, okay, let's say our domain is the number of barbecues. It's our input, number of barbecues assembled. And the Y, it's telling us, which is also our range, is the, or the output, is the pay that he gets. So we can say his pay is equal to the number of barbecues, and he gets well, let's say it's one barbecue, he gets $8, so it's 8 times the number of barbecues. So we can call that y equals 8x. Where my input is the x and my output is the y. The output's like the result. Now, when they give you questions like this, they're not going to just ask you to translate it. They're going to ask you to use it. So they're going to give you a second piece of data, and they're going to say, well, what happens if he has 20 barbecues? Once you write the rule, can you substitute it in and utilize it? So we substitute in, and we get y equals 160. Okay? Makes $160. All right. Todd is 3 years older than his brother, Mark. If Mark is X years old and Todd is Y years old, then write a rule that relates their age over time. So X is our domain, and it's Mark's age, and Y is our range, or our output, and that's Todd's age. And so we're going to use this. It says Todd, so I'm going to write a Y for Todd. Is my equals 3 older than Mark. So we have to do Mark is X plus 3. Remember, we have that than, so instead of this over here and the 3 over here, we're going to have to crisscross it because it has the word than. Okay? Now, my output is my Y, and my input is the X. So whatever Mark's age, Todd's age is dependent on it. Now, what happens when Mark is 28? We substitute it in for the input, and we get that Todd is 31 years old. All right. When we first taught you, we taught you about how to figure out data for an equation. We started with a table. So we can make the XY table based on this rule or this equation. And so when x is 1, or we can even start with 0, but when x is, let's start with the negative since my thing is negative 2. Negative 2 times 2 is negative 4. Negative 1 times 2 is, and we just substitute it in by filling in our input. Originally, when I taught you how to do this, we went like this, and we made a 3-way table. And I went 2x equals y. So when x is negative 2, 2 times negative 2 is negative 4. So we're doing that with all of our values. So when x is 1, it'll be 2, and when x is 2, it'll be 4. Okay? Now, to map means you put all of the input values, all right, we take all of our input values with no repeats. And we take all of our output values with no repeats, and we put them into these long little oval shapes. And so all the possible inputs, I list them. And then for my outputs, I'm going to draw an arrow to whatever they go with. So really what this means is I have negative 2, comma, negative 4, ordered pair. This means negative 1, negative 2. This means 0, comma, 0. This means 1, comma, 2. And the next one is 2, comma, 4. Okay? Now we call that a function because there's no repeated x's, which we'll talk about in a minute. Or each x value has only one output. Okay? Now, a relation is any set of ordered pairs. A function is a type of relation where there's exactly one output for every input, meaning there's no repeated x's. So in this first function that I give you in a table, is this a function? Well, we know that if we put it in the map, I'm going to list all my x values. All right, so now I'm going to list my possible y values. Now notice 7's repeated. I don't need to write that twice. I only list it once. Okay, so 1 goes with a 6, so I make an arrow to the 6. The 2 also goes to the 7, and the 3 also goes to the 7. Now, in the table, we can see that there's no repeated x values, so this would be a function. In the map, the way we see that is if we don't have two lines coming out of the inputs, then it's a function. This is how it looks. Now let's take that and compare it to something like where we do have repeated x values. Here we can see, I'm listing my values. Okay, here we can see the repeated x values, and here you can see 1 goes with 6, 2 goes, 1 goes with 7, and 2 goes with 7. And right here, where you have the two lines coming out of the same x, is where we see it is not a function. So here's what it looks like with a map, and here's what it looks like with a table when something is not a function. Okay. Now, I'm going to remind you, what does this mean when we see the map? This really represents ordered pairs. This is 1, 6, and then we have a 1, 7, and then there's a 2, 7. It's a relation, but this relation is not a function. All right. Function is a rule or an equation where there is exactly one output for every input, meaning there are no repeated x's. For every x value, there's exactly one y value. You can have repeated y values, but not repeated x values. So when we have no repeated x values, then we say it's a function. So this would be a function. Oops. On the next one, there's no repeated x values, so this would be a function. 1 and -1 are not repeated. They're different values because their signs are different. It doesn't matter if the y's repeat, it's the x's can't repeat for it to be a function. Okay? Now we see that our x's repeat with the number 1, so this is not a function. Okay? All right, determine whether the equation is a function. So I'm going to be taking, now you can do that three-way table. I've got x, we have our output y, and here I'm going to put what we're doing, the absolute value of x equals. So let's start with a negative, -2. So I'm doing the absolute value of -2 is 2. Let's start with -1. The absolute value of -1, is 1, remember? It's distance from 0, 0. Okay? We can take 1. The absolute value of 1 is 1. The absolute value of 2 is 2. 2. And you can see here that when we have absolute value, there's no repeated, where x is the input and y is the output. There are no repeated values. Okay, if we look at it on our map, you can see there are not two lines that come out of the inputs. If I make x the output and y the input, okay, I switch it around and I make what's happening. This time I'm inputting for the y and my output becomes the x. So if I have -2, then that would mean that x is 2. If I have -1, that means it's 1. If I have the input is 0, and it's still 0. If the input is -1 and +1, and now we can see in this case we have repeated x's. So when x equals the absolute value of y, it is not a function. You can see it in the map because right here we have two lines coming out of the same input. Okay, not a function. Okay, pause the recording and see if you can figure out if these are functions or not a function. Now let's check our work. Number 1 is a function. Number 2 is not a function because -3 repeats. Number 3 is a function because there are no repeated x values. And number 4 is not a function because there is no repeated, there are repeated x's. -2 is repeated. This means -2, 3 and -2, 4. All right, now we're going to write the function rule. Now, we talked about this before. We can look at our change in our y's. We're used to seeing this where it's up and down. And one thing we did back last semester is we looked at okay. Go to 3 just like they have. Okay, what we're looking at is our change in our y over our change in our x. Now remember, where does this come from? Remember our slope in y equals mx plus b? We're trying to figure out that equation based on this. Okay? I'm going to remind you our m we can find by our change in our, remember m is equal to y2 minus y1 over x2 minus x1. I've shortened that by doing the change. The triangle means change in x over change in y. So I can see that my change in my y is plus 4. It's a constant rate of change. So if it's constant, I can just do this. And my change here is plus 1. So my m is going to be a 4. Y equals 4x. Now, my y-intercept. Y-intercept is when x equals 0. So we look at when x equals 0, my y is 0. So it's just y equals 4x. All right, I want you to pause the recording and see if you can try number 2. Now let's check our work. Whoops. Okay, so let's quickly go through. I know that my I'm looking for my m and my b. It's the change in the y over the change in the x. We don't need to do the full, so the change in the y, it's increasing by 1 over the change, the increase here is also, so this equals 1. So my m is equal to 1. So in y equals mx plus b, we know that it's y equals 1x. And when I go to my y-intercept, where x is 0, my b is 5. And that's why it's y equals x plus 5. Okay, let's try the next one. Once you finish up the other two, now let's check the work. All right, so I'm noticing my change in my y, I know it's going to be y equals, my change in my y is 1/2. It's increasing by 1/2. So it's 1/2. And over here, over 1, my x is by 1, so it's 1/2. And there is no y-intercept, so I'm just going to write plus 0. We don't need to write plus 0. We can just write y equals 1/2. All right, next one. My change in my y is increasing by 3. It's 3 over 1. So it's y equals 3x. And then I go to my y-intercept. It's plus 2. That, my friends, I believe that's it. Let's see. Oh, no, function notation, sorry. All right, function notation, here we go. Function notation is just a fancy way to write. So we've got when x is 1, y is 5. I substitute, how are they getting that? They substitute 1 in. 2 times 1 plus 3 is 5. So when x is 2, we can figure it'll be 7. When x is 3, it'll be 9. 4, it'll be 11. So with function notation, all we're really doing is substituting that y. This is a fancy way to write. It doesn't mean f times x. It's a fancy way to write the f of x. Y. So what they're saying is, we could say the function when x is 1 is equal to 2x plus 3. So I would substitute when x is 1, I could substitute that x for 1. Okay, so we would say the f of 1, the function of 1, is equal to 5. I could say the function of 2, and then I'm substituting 2 times 2 plus 3, so the function of 2 is equal to 7. Okay? How would I write the next one? Okay, the f of 3 equals 9. And the next one would be the f of 4 equals 11. Could I figure out the next? I could. The f of 5 equals 2 times 5 plus 3. So the f of 5 is equal to 13. Okay? I know you're wanting to look at the pattern going up and down, but we really have to look at our rule, because it doesn't matter what happens if I ask you for the 100th term. All right, so now I have two different kinds of functions. We have a g function and an h function. And so depending on what they, like over here, they're telling us use the g function and they want us to substitute 4. So I would do 2 times 4, and so the g of 4 is equal to 8. This time I'm using the h function. So I'm doing the h and I'm substituting right here with that negative 2. So I do 4 times negative 2 plus 1. So that becomes negative 8 plus 1. So the h of negative 2, and you need to write that when we're working in function notation, equals negative 7. I want you to pause the recording and try the next couple on your own. Now let's check our work. Number 3, you should have gotten negative 6. The g of negative 3. Okay. The h should be negative 3. The h of negative 1 equals 3. It's 25. And this is 18. Now we get a little bit more complicated. So, okay, we're doing more than just linear functions. Okay, you can see right here we have a quadratic because x is squared. So we're doing the g of 4. Let's try, I'd like you guys to try 1 through 5 on your own. 1 through 4. Now let's check your work. So the first one, we're going to use the g function. The second one, I'm substituting a 2 into the h function. All right, now it gets a little trickier here because we have to find the value of the h function using 4. So I'm doing 3 times 4 minus 2, and that simplifies to 10, plus the g function of 1. So it would be 1 squared, so that's 1. So that simplifies to 11. The h of 4 plus the g of 1, and we read it g of 1, not g times 1. In this case, it doesn't mean multiplication. It's 11. We're going to try the next one, the h of negative 5. So I'm doing 3 times negative 5 minus 2. Whatever that result is, then I'm going to do g to the negative 2 is squared. So this becomes 15. Negative 15 minus 2 is negative 17 times 4. So that makes 68, negative 68. Okay? Now, this is very important. Inside out. So h of 3, the h of 3 is, so I first have to do this function. We work inside out. So I'm going to find the value of that, and that would be 9 minus 2. So the h of 3 is a 9. Now we have to put it into the g function. Right? And the g function is, we're doing 9 squared, and so that makes it 81. Let's check our work. We work inside out. Oh, wow, I got the wrong thing, so I guess it'd be 41.9. Oh, there we go. It was 3 times 3 minus the 2. I forgot to do that, so that's 7. And then so the h of 3 is 7. And then I take 7 and I have to put it into the g function, so that would be 49. Okay, you try the next one, number 8. All right, let's check our work. The g of 2 is 4. And then when I put it into the h function, 3 times 4 is 12, minus 2 is 10. All right, evaluating the function over a domain. This is the part, I don't know if you remember, it's a little bit of a pain in the butt, but we have to write this 3 times. So I have to substitute it in 3 times. The f of negative 1 equals 4 times negative 1. So the f of negative 1 equals negative 4. The f of 0 equals 4 times 0. So the f of 0 equals 0. And then I'm going to do it a third time. The f of 2 equals 4 times 2. And so the f of 2 equals 8. Now, you'll notice that when I do this on my PowerPoint, and I do not want you to do this, because if you put these out of order, the 3 answers that I had over here, which were, you can put them in a solution set, negative 4, 0, and 8. But if you put them out of order and then you don't attach them to what they're connected with, you'll get all 3 wrong, and it's a big way to lose points. So I prefer your answers be like that. However, this is acceptable. Just has to be in order. It is assumed that whatever the first answer is, it's with the first input. The second answer is with the second input, and the third answer is for the third input. So pause and try the next one on your own. All right, let's check our work. For the second one, you should have negative 12, negative 9, and negative 3. And for the third one, you have 0, 1, and 3. Whoops. And that is our lesson.